Question 5 says factorize 2m squared minus 8n squared. You have 2m squared minus 8n squared. This is not a strict factorization question. It has difference of two squares in it, where you have a squared minus b squared. If you factorize a squared minus b squared, you have a plus b in bracket a minus b. But first, we have to take what is common in both of them out first. We have 2 here and also have 2 in 8. So we'll bring out 2. Take out 2. Let's say you have 2m squared divided by 2, because you brought out 2 since it's common in both 2m squared and 8n squared. The 2 will cancel the 2. You'll be left with m squared at m squared minus. You have 8n squared. 2 is also in 8n squared. So let's say you have 8n squared divided by 2. The 2 will cancel 2. 2 into 1. 2 in 8 is 4. You have what is left as 4n squared. 4n squared. You can close your bracket. Now that we have taken 2 off, we have not ended our factorization. And looking at the options, this might give us an insight into the kind of question we're solving. This shows you that the question has a difference of two squares in it. That's a factorization method that works in this case. Where you have a squared minus b squared will give you a plus b in close bracket a minus b in second bracket. We have 2 into open bracket m squared minus 4n squared. Now that you have gotten 2 outside, if you're very sharp with factorization that regards difference of two squares, you'll be able to spot this, that this requires factorization by difference of two squares. Now you have 2 into open bracket m squared minus, you can break this 4 into 2 times 2, which is the same thing as 2 squared. So you can have 4 as 2 squared n squared close bracket. You've broken down 4 into 2 squared and you have n squared. Normally you can't factorize this 2 because they have nothing directly in common. But under difference of two squares, you can solve this question. Next, you have 2 into bracket m squared minus 2n all squared close bracket. At this point, you can group them as one. You have 2 squared and n squared, provided they have the same power and they are multiplying themselves, or they are linked to themselves by multiplication. You can group them together and power them by one power that they have in common. So this is allowed in math. If you have a question that requires this, it is allowed. You can do it like this. Now that you have this, you can now use difference of two squares, where you have a plus b and a minus b. It works where the first algebraic expression has a power of 2 subtracted by the second one with the power of 2. Once you have a question in this format, same as this, you have m squared minus 2n squared. This is your a, m is your a, and 2n is your b. So you have 2 into open bracket. We will factorize what is in the bracket. You now have m plus 2n in one bracket, then m minus 2n in the second bracket. So you have them in this format. The first one gets a positive, the second one gets a negative. And like I said earlier, you can write the one with the minus first before the one in addition. It's still the same thing. You can close your bracket here, it doesn't matter. You can write as 2 in bracket m minus 2n m plus 2n. Now it depends on the option. Notice that the options doesn't have the one with plus before the minus. You have the one with minus before the plus. So this is our final answer. That's 2 into open bracket m minus 2n close bracket open bracket m plus 2n close bracket. Of the options, the answer is E, where you have 2 into open bracket m minus 2n close bracket open bracket m plus 2n close bracket. You can check the options and see this is the only one that fits our answer. In summary, for this question, it contains factorization by difference of two squares. So what you have to do first, you take out what is common in them. In terms of the number, that's 2 is common in both of them. Then you create a difference of two square kind of question where you can factorize